talk to you about our geometric sculpture.
We were fortunate enough to be picked by our teachers and the community members to be in the top 3 for our design.
We feel that since we have all the right information and the right sources, that this will help us make our dream sculpture for this school.
We're here to prove that to you today.
If you have any questions, please wait till the end and we'll answer them then. First, we are going to talk about the scale. The scale is 1 inch equals 1 foot, and in the picture to the right is where our location would be, where we put our sculpture, and the actual size.
Next, we're going to be talking about some of the changes that we decided to make to our sculpture. The first is the wideness of the sphere strips here. They used to be 1/2 of a foot or 1/2 inch, and then we changed them into a 4th foot instead of half, so you could easily see the go-hawk in the middle. And next, the attachment piece, we like to call it, that we use to attach the go-hawk to the sculpture. We're going to have that being cut in half, so as you can see to the model to the right, that's what it'll look like. And then finally, the base is going to become a bench for people to sit on, and we'll further elaborate that as we go on.
Next is the type of metal we will be using. We will be using cold-rolled steel, and some advantages to that is it's thicker metal, shinier in color, you can bend it and it rusts over time, but it's not like a bad rust, we just wanted a little rust to it.
And then the dimensions of metal and the amount of sheets we will be needing. We need 3 4x8 sheets of metal, and some scraps will be left over. And we're getting this metal through my grandpa, and he works at the green John Deere implement. And so we'll be getting that through him, and the rest of the scraps that we won't be needing, we would be giving to the high school. And I have a sample. This steel is rolled with heat, but with ours it's going to be being rolled with no heat, so it's going to be shinier in color, but it's going to be the same thickness, and Kelsey's going to pass that around. So next we're going into the cost, expenses, and donations.
The cost per sheet is $3.36, and this is for 1 square foot. The total metal cost before the donations we had was $322.71, and after the donations it came down to $161.36. And on the sculpture right here, we are going to write down some character counts. And the lettering cost would be $15, so then the total lettering cost would be $105.
And going on to the labor would include like the welding, the cutting, and the concrete base, and everything else like that. The welding and the cutting is going to be around $200 by itself, but adding the concrete base and those other things, it's going to be around $395. So if you put that into a total, this is with all the donations added to that, it's around $211.36. So half of the metal cost is being donated by my grandpa, including any possible labor that he could help with, since he's very educated in that field and he knows how to work all the tools. And Mr. Stack and Mr. Roney are donating $400, and Waverly Family Dentistry is donating $50. But if our sculpture, if we're grateful enough to move on and to be able to build it, they'd be willing to donate more towards that. Next, we're going to be talking about the nets. So the first picture you see in the upper left-hand corner is the top base, which is right here, and it's 1/2 of a foot tall by 3 feet in width and 3 feet in length. And the next net we have is the bottom base, and the top base is going to be attached to this to make the bench, and that's 1 foot tall by 4 feet wide and 4 feet in length. So we'd be attaching them on top of each other to kind of make that bench, if you can see that. That's how the bench would be. And then we have the sphere net. And so we have the sphere the strips are 1/4 of a foot in width and 6 feet tall, which we'd bend down to 4 feet. And then the go-hawk and the connector piece we have, the connector is 1/4 of a foot wide by 4 feet in height, and we'd be cutting that in half, obviously. And the go-hawk is 3/4 of a foot by 2 feet, and that's willing to change because of any extra metal we may use to make it bigger, or how we would be cutting it out. Next is our cookie cutter sheets, what we like to call them. These are pieces of paper that we've modeled to kind of do the scale down to 1 foot equals 1 inch, and so it's a 4x8 piece. And so we've got on the first piece here, we've got all of the sphere strips cut out there. We've got 2 length strips for the bottom base. We've got all of the length strips for the top base, which is right here. We have the Go Hawk and connector in this one also. And then the next one right here is just the top and bottoms, base 1 and base 2 is included in that one. And finally we have this model here, which is the bottom base is extra length pieces that we didn't get covered, and the top base is top and bottom pieces. And if you've seen in these past pictures, there's been some area shaded out, and that's the extra scrap metal that we won't be using.
Next is our terminology and our connections. Our terminology is, it's about the size of an average two-door refrigerator, and our connection is with Grace's grandpa. Like she said earlier, he works at John Deere Implements in Green, Iowa, and he's a machine and welding parts manager. Our comparisons in relationship is our scale is 1 to 12, our surface area is 1 to 144, and volume is 1 to 1,728.
All right, and we have finally our sources. We didn't use any websites for this. We used Mr. Benham, so thank you, Mr. Benham, and my grandpa for all of the information for the metal and how we would be needing to cut it out. So that concludes our presentation, and we thank you all for listening. And if you guys have any more questions, we'd be willing to answer them.
It's good. I just want to clarify, will you guys go back to your cost sheet?
Sure.
So your total cost is that you've added everything together, and then have you subtracted the 450?
The 450 for the
Well, when I'm just,
yeah.
and I'm
Donation money?
well, I'm not sure how to ask this. You've got your total metal cost, your lettering cost, your total lettering cost. So if I look at total metal, total lettering, labor cost, total cost, it just, you know, the way I think about it, it should add up. And since it doesn't add up, I'm thinking, okay, am I supposed to subtract? You know,
Okay.
can you just clarify that for
Yeah.
me? You understand what I'm asking you?
With our total cost, we have the 161, which is the donated from my grandpa. We have the 105 for the lettering, and then we have the labor added together, and then we subtracted the 450 from.
And that's where you get the 211.36.
Yes.
So that's the remaining, right?
Yes,
That's what it would
that's what it would cost. And so if you look at it, since you're donating
That's the part you need to
400,
fundraise.
you'll still have that extra 200.
So do you guys have anything else or anything about how you're gonna pay for that? I mean, you've got some cut costs, you've got some
Yep.
donated labor. Do you have anything about the 211.36 as far as?
Well, we were thinking that would come from the money that you would be donating, that 400 that you and Mr. Roney are compiling together, and you would still have that extra around $200.
Yeah, what's the total cost, what is your guys' total cost of the project without the donations?
211. Oh, without the donations?
Yep,
That would be around, I would say, 700.
okay.
600.
So you're getting
Yep.
$500 donated, so there's 211 left over that
Yep.
we have to come up with?
No,
I'm missing it.
the 211 is the final payment, and then if Mr. Stack would donate the 400, we'd still have the 200 remaining, so we wouldn't have to